Well, now we're going to work through nearly every aspect of an example problem where we take a stone off the side of a building and throw it upward and see what happens. We have a stone and it's thrown from the top of a building with an initial velocity of 20 meters per second straight upward at an initial height of 50 meters above the ground. Now, the stone goes up and it just misses the edge of the roof on the way down. You're going to determine the time needed for the stone to reach its maximum height, that maximum height, the time needed for the stone to return to the height from which it was thrown and its velocity at that instant, and then the total time needed for the stone to reach the ground. So that's the total time from here up and all the way back down. And then the velocity and the position for the stone at some time. It can be any time, but we're saying that we'll evaluate the velocity and the position at t is equal to 5 seconds.
So here we have a stone, and it's being thrown from the top of a building with an initial velocity of 20 meters per second straight upward at an initial height of 50 meters off the ground. So our building is 50 meters above the ground, the top of our building. Now, when the stone comes back down, it just misses the edge of the roof on the way down. So we can assume that this motion is pretty much vertical, straight up and down. Okay, so the first thing, we're going to determine a lot of stuff here, give you a lot of good examples. But the first thing we're going to determine is the time needed for our stone to reach its maximum height. So we're going to find the time at y max, at its maximum height here. Okay, so this is our unknown, t at y max. The things that we do know, we know our initial speed. We know acceleration in the vertical direction is always minus 9.8 meters per second squared. Always, that's our acceleration in the y direction, okay? And whenever, a very important thing to remember as well, whenever an object reaches its maximum height, if it's experiencing projectile motion, if we launch an object upward, whenever it reaches its maximum height, its velocity at its maximum height, or the apex of its curve, its velocity there in the y direction is always 0. So the y velocity right here for our stone is going to be 0 meters per second at its max height. Okay. So that's another thing that we know. We know acceleration, initial, final velocity. We can use that to find the time at our peak height, maximum height. So let's look for an equation where we know v initial, v final, we know acceleration, and we need to find t. Well, we also know the initial y position. I'm going to say, I can set up my coordinate system however I like, but I'm going to say right here at the edge of my building, that's where y is equal to 0. So if you think about your coordinate system, if we started our coordinate system here, positive y would be everything above the edge of this building. Negative y would be everything below the edge of this building. So we also know the initial position for our stone, which is going to be y equals 0. Okay, so let's see, what equation can we use from our equation sheet? Let's start with this one. We've got our final velocity is equal to our acceleration times time plus our initial velocity. So we know final velocity, we know initial, we know the acceleration. All we just need to solve it for is time. Now let's go ahead and solve this equation for t then. So we have v, I'm going to subtract v0 from both sides here, v naught from both sides. So on this side of the equation, we're going to have v minus v naught is equal to a t. Now we divide both sides of our equation by the acceleration in order to get t alone by itself. So we have that t is equal to v minus v naught over a. So the final velocity, that's the velocity at the max height, that's 0. 0 minus our initial speed was 20 meters per second divided by our acceleration due to gravity, minus 9.8 meter per second squared. So we've got a negative on top of a negative, and you divide those by each other, you'll get back out a positive value. So then t is going to be equal to 20 divided by 9.8. So we get that our time to reach that max height is 2.04 seconds. So I'm going to put that in here, 2.04 seconds. Now the next thing we want to find is, what is this maximum height of our stone throw? Now we know an additional known. We know the time it takes for our stone to reach that maximum height. So we want to find an equation that at least has y final in the equation, and it has all these other knowns that we've already found. T to get there, initial and final velocity, and our acceleration. So let's go with this equation, y equals 1/2 at squared plus v0 t v naught plus y naught, y sub 0, our initial y position. Okay, so we know that our initial y position was 0. Starting here at the edge of the building, we defined that as 0. We know our initial velocity was 20 meters per second. We know our acceleration and time. So let's go ahead and plug those in. 1/2 minus 9.8 meters per second squared times the time to get there, 2.04 seconds squared, plus our initial velocity, 20 meters per second, times the time, 2.04 seconds. Now, plugging all that in, don't forget to square the 2.04 seconds. I forgot to do that the first time I worked through this problem. Don't forget about the minus sign here on your 9.8. If you forget the minus sign, you're going to end up with too big of a number. Okay, so we have y is equal to minus 20.4 meters plus this term here is 40.8 meters. So y, its maximum height, is equal to 20.4 meters. That's y max, 20.4 meters. All right, now we're going to find the time needed for our stone, the total time, to return to the height from which it was thrown and its velocity at that instant. Okay, so the way that we're going to solve this problem, let's say that our initial starting point here was A. It went up to its max height of B, and then it comes back down again to point C. So we want to find the total time to go from A to B to C. Okay, we already found over here in part A the time to go from position A to position B. What we can do is find the time it takes to go from B to C, and then we can add that to the time it takes to go from A to B. So we got time A to B plus time B to C. That will give us the total time for our ball to go up and come back down again. So we'll say that that time is equal to TAB plus TBC. And remember, this TAB was already 2.04 seconds. Okay, so right now we're looking for this quantity right here. So we start with our point B, and then we're going to point C to find the time for that bit first. Okay, so let's start with this equation that I wrote up right here. Okay, we've got our final y position, which will be at point C, is equal to 1/2 at squared plus v naught t. That initial velocity is coming from point B. The velocity at point B of our stone is 0 because it's reached its maximum height. Okay. And then we've got our initial y position. That's the y position here at point B. That would be our 20.4 meters. Okay. So we've got one term that's already 0. So we've got yc is equal to 1/2 at squared plus y0. Remember, we're solving this equation for t here. So yc, our y position here at point C is 0. We've got 0 is equal to 1/2 at squared plus y0. we're going to solve this now for t. That's what we're trying to solve for. T, B, C, the time to go from here to here. So let's see, I'm going to subtract y0 over to the other side. So minus y0 equals 1/2 a t, the time it takes to go from b to c, squared. Well, let's see what we could do. We could divide both sides by 1/2 times a, or what we can go ahead and do now is we could multiply both sides by 2. If we multiply both sides by 2, we're going to get rid of this 1/2 on this side, and then on this side of the equation we've got minus 2y0 equals a t squared. Okay, divide both sides by a. Then we've got the time to go from b to c squared is equal to minus 2y0 over a. Okay, now to get rid of that squared on the time, you take the square root of both sides. So then you have that t, time to go from b to c, is equal to the square root of minus 2 initial y position over a. So that's going to be the square root of minus 2 times our initial y position at point B was 20.4 meters, and then we're dividing that by minus 9.8 meters per second squared. And so we see that we have a negative on top of a negative. We're dividing a negative by negative, so our end result's going to be positive. So the quantity inside our square root will be positive, so you don't have to worry about anything weird happening there. Okay, you're not going to get any errors when you try to take the square root of that number. And so then we find that the time to go from B to C is also 2.04 seconds. Okay, so then the time to go from B to C is 2.04 seconds. So the total time to go from A to C is 2.04 seconds plus 2.04 seconds. So 4.08 seconds is what we were looking for. So t here is 4.08 seconds. So you see, the interesting thing here is that the time it takes our stone to reach its max height is the same as the time it takes the stone to get from that max height back down to the position from where it started. And so then the total time to go from A to C is going to be twice the time it takes for the stone to either go from A to B or B to C. Okay, that's always the case for any projectile motion. Okay, now the second part of that problem, or part C here, is to find the velocity at this instant. The velocity when our ball gets back to the initial height from where it started again. Okay, so in order to find that speed, much simpler than all this work that we did right here, we can use the equation v is equal to at plus v naught, right? And for this, we can start with point A as our initial starting position and point C as our final starting position. Okay, so we're solving for the final velocity, the velocity when we get to point C, and that's equal to, our acceleration is minus 9.8 meters per second squared. We already found the time it takes to go from A to C, and that was our 4.08 seconds. And then we're going to plus, I'm running out of room here, plus our initial speed that the stone was thrown with, which is 20 meters per second. Okay, so then our velocity when we pass through point C is going to be minus 40 meters per second, and then we've got plus our 20 meters per second. So the velocity when it's moving through point C is minus 20 meters per second. Okay? Let's put that here. V is equal to minus 20 meters per second. So again, this is interesting because the time it took to go from A to B was the time it took to go from B to C. If our initial speed at which we tossed the ball or the stone upward was 20 meters per second, the final speed at which it's moving back through the same position from which it started is going to be negative 20 meters per second. So what if I asked you to find the velocity and position of our stone at t is equal to 5 seconds? Okay, so if we are thinking back to our points here in our trajectory, A was our starting point, B is max height, C is when we come back through the edge of the building here, the same place as our initial height. And then let's call D if the stone were to reach all the way down to the ground. And then let's call point E right here our position at t is equal to 5 seconds. And so if I asked you to find the velocity and speed at t is equal to 5 seconds, you'd be somewhere over here in our trajectory, okay? And in order to find the velocity there, you would use this equation, v is equal to acceleration times time plus v naught, okay? You can start v naught from anywhere you want here, but let's say, as long as you know the times to go from that point to point E, but we're saying that it takes a total of 5 seconds to get from point A to point E here. That was a given for us. So we're going to start from our initial point at point A, and that would be our initial velocity here, okay? And so then our velocity at point E here would be equal to our acceleration due to gravity, our minus 9.8 meters per second squared, times our time at point E, and that would be 5 seconds, and then plus our initial velocity at point A. And so that would be your 20 meters per second, okay? I'm not going to solve that fully here, but then if you solve this, you should get a negative velocity if you're going to get to that point there, okay? And then in order to find the y position right here, you would start with y is equal to 1/2 a t squared plus v naught t plus y naught, okay? And you would start with your initial position again here at point A. Your final position would be here at point E, so y0 would be 0 because we're starting there, which we've defined as y is equal to 0. Our initial velocity is going to come from our 20 meters per second. The total time it takes to go from A to B to C to E was 5 seconds. We know our acceleration due to gravity, okay? And then plugging all those in, that would also give us our position. Now the final part of this problem, we are going to find the total time needed for our stone to reach the ground. So the time to go from A to B to C all the way down to D, okay? So we can use y is equal to 1/2 a t squared plus v0t plus y0, okay? y0 is 0. We're starting at point A, which we've defined to be sitting at y is equal to 0. Our final y position, since we said y is equal to 0 here, all the way down then at the bottom of our building is going to be minus 50 meters. That's equal to 1/2. Our acceleration is minus 9.8 meters per second squared times t squared plus our initial speed at point A was 20 meters per second times time. Okay, we've got a quadratic here. We've got t squared, and then we've got an additional term here. So let's see. Let us move the minus 50 meters over to the other side of the equation. So we're going to add 50 meters from, so if we do plus 50 meters here, that cancels. We can add 50 meters over on this side. So we've got 0 equals 1/2 times minus 9.8, that's minus 4.9 meters per second squared, all of that, times t squared, plus And then we have our 20 meters per second times t plus our 50 meters. Okay, so here we've got, for our quadratic, this is our term that we call A. This is our term here that we call B. And then this is our term C here. Maybe we're not dividing by A, B, and C. I'm just labeling those as that, okay? And so then we'll use our quadratic formula in order to get t. So let's go up here. T is equal to our quadratic formula. We've got negative b, so minus 20. I'm going to ignore the units, plus or minus the square root of b squared. So it's going to be 20 squared minus 4 times a, be minus 4.9, and then times c, which is 50. Okay, so we've got our negative b plus or minus the square root of b squared minus 4ac, and then we divide that whole thing by 2 times a, or minus 4.9. Okay, minus 20 plus or minus the square root of 20 squared is 400. And then we've got minus 4 times minus 4.9 times 50. Okay, and so if we do this whole quantity right here, we take minus 4.9 times 50 and then multiply it by negative 4. We get that that whole quantity is plus 980. Okay, and we're dividing all of that by minus 9.8, which is 2 times minus 4.9. Okay, so that's minus 20 plus or minus the square root of 1,380 and dividing all of that by minus 9.8. Okay, now let's see. Okay, one more step. Minus 20 plus or minus the square root of 1,380 is 37.1, okay, all over minus 9.8. So t could be minus 2 plus 37.1 divided by 9.8, and that would give you negative 1.74 seconds, or t could be minus 20 minus 37.1 divided by, oh, that's a minus sign there, divided by minus 9.8, and that is positive 5.83 seconds, okay? And we want to choose the positive quantity of these two, so t would then be plus 5.83 seconds, the total time for our stone to get from point A to point D.